So, banked curves. Fairly simple concept, not very difficult. Of course, there will be examples to help support what I say in this little lesson. Okay, so let's say you have an object on an unbanked surface, just absolutely level, and the forces acting on the object are the weight, pulling it downwards, and the normal force. So, due to the flat surface, it's pushing the object upwards. Both of these forces are acting in the vertical direction, so they have no component. Horizontal component, that is. So, there's no force able to move it, and it won't turn, it won't do anything, it'll just stay still. So, on the other hand, if you have an object on a banked turn, the normal force, which will always be perpendicular to the surface, will no longer be vertical. See, it will be at an angle. That depends on the angle of the road, of course. The normal force has a horizontal component now, since it's turned. Since it's at an angle. This component can act as centripetal force on the car. So, the car will have to move with just the right speed so that it needs a centripetal force to equal this available force. Given the right speed, a car could safely negotiate a banked curve even if the road is covered with perfectly smooth ice. And that all depends on the coefficient of friction between the tires and the road. So for those who don't really get the picture that I drew before, here's a picture that might make it easier to understand. So you have the horizontal component, the vertical component, and the normal force, the weight, and the angle. So, now let's look at the equations relating to this. So, in the vertical direction, you will have the normal force times cosine of theta. Sorry for these little erasings. I don't know what's happening. So, the normal force times the cosine of theta will be equal to the weight. And with that formula, you can derive a fairly simple formula, which is the normal force is equal to the weight divided by the cosine of theta. So now let's look at the horizontal component of banked curves. So, the net force is equal to the centripetal force in these types of situations. So, the weight times the tangent of theta would be equal to the mass times the volume squared divided by the radius, which is also the centripetal acceleration. Or force, that is, not centripetal acceleration. And those are basically the only formulas you need to know for the horizontal and the vertical aspects of banked curves. Again, it's very easy to confuse the vertical and horizontal components, but if you get them down, you should be able to do all the following examples pretty easily.